Hello, I'm Andrew,
And I'm Gary.
and welcome to this online professional development resource where we're going to be reviewing the PhET online resources for maths and science. We've selected this site because it fits nicely within all three of NEIS's TPAC framework, which is the Technological Pedagogy and Content Knowledge Model. The PhET site allows science and maths teachers to be armed with a series of interactive tools that they can use in their classroom to model either science or maths content.
So to begin with, we're going to be discussing how you can use PhET in a physics classroom or a physics setting. And in particular today, we've chosen forces because they're a cornerstone of the VCE study design for motion, which is a core aspect of physics. The applet is designed to provide students with a more tactile way of approaching forces and how they interact with one another and how you can balance them out. So here's an image of the demo that we're going to be showing or showcasing today. And as you can see, there's a few people tugging the rope on each side. And at this stage, the left force is greater than the right force. We've got two people tugging on the left, whereas the right person in red only has one person, so there's a smaller force there. And we'll see that in a moment when we demonstrate the application. Okay, so here we have launched the link to the PhET page, and we're going to go into this first tab here, which is the net force option. Okay, so we click on that, and immediately we're brought up to this screen where there's a cart in the middle, and we've got some rope over here and over here. And what we can do is we can put these little people onto the ropes. And so if we put two people equal distance apart and of equal size, and they start to pull, the cart doesn't go anywhere. Okay, so you can use this in your classrooms to get students to model how equal and opposite forces will balance out. However, if we now add another person in, and we again try, we can see this cart will start to move, because there's now a greater force on the left-hand side. Interestingly, if we take a person off, you'll notice the cart's still moving. And this is a really good example for students to go through, either with the teacher or just think through on their own, because students might initially think, oh, the person's been pulled off the cart without pausing the application hasn't caught up. But in actual fact, what's happening is because there was already some force, inertia says that now there's a net force, it's a net force of 0, it's just going to keep going the way it was until some other force counteracts. And this application is particularly useful because you can get students to do it on their iPads or the device they've got at hand, and they can also turn on things like values and show the sum of forces to give them a sort of more mathematical framework to understand what's going on. There are other applications, we won't go through them today, but at your leisure feel free to explore them and make use of them. So here's an example of the values. This time red force is greater at 150 newtons compared to the left force of 50. And there's a sum of force of 100 newtons going to the right. And now in terms of what sort of literature we have to back this up, I mean, obviously we have the VCE study design, in which forces are a cornerstone, as I previously mentioned. There's also some research done by Naylor and Wilson in 1998, which discusses that if you use cartoons in physics, it often acts as a more engaging means for students to interact with the content, rather than just having, say, questions on a whiteboard. Hyman and Perkins also suggest that interactive simulations running through a web browser can be highly effective. So based on these two pieces of literature, students would be well equipped if they had their own simulations to work with. And so when using these simulations in your own physics classrooms, I mean, the main task is to make sure that students are engaged. And to this end, there's a certain amount of time where you have to just let them play with the application and discover things for themselves. Some good teacher questions are, what is happening when the forces pulling in each direction are equal? And what happens when they're not equal?
Okay, now we're going to have a look at how PhET can be useful in the maths classroom. Trigonometry is taught at many levels throughout high school, all the way from Year 8 through to VCE in maths methods. This is a link to the PhET demo, which is called Trig Tour. So we're going to just launch that link now. And we can see here the Trig Tour within PhET. Now this is a what's called a unit circle of length of radius 1, On the right, we can see a range of different options. So we can see a sine wave, a cos wave, so if I pick cos, the graph at the bottom will change. If we go back to sine, we can now see a sine wave. Students can start to model or move this unit circle around and see a whole range of different values. So we can see that that angle's now moved to 120 degrees. We can change that to radians, which is an important concept. If we go multiple times around the circle, we can see how it's linking this unit circle down to where we are on the graph below. So this is a really useful way to introduce some of the concepts of trigonometry. We can even see that you can go into negative numbers and give students something to play with as you start to introduce the topic. If we quickly come back to a cos wave, we can turn on some of these extra options of special angles or labels, and this will start to show and really reinforce for students. If we've got an angle at, say, I'll come back to the start, say at 30 degrees, which if we go back to radians, we can see that's at 30 degrees. We have a special value of √3/2 for cos, or we have a value of 1/2 for sine, and all of these different special points are jumped to. Now these are very useful for students when they're starting to graph trigonometry functions or circular functions, and it can also help with them identifying whether the values might be negative or positive, which can also be a real struggle for students as they're learning trigonometry. Now, using Trig2 in the classroom has been reinforced by some research from Kendall and Stacey. They found back in 1996 that there's two real strategies for teaching trig, either the Sokotoa model, which is where you're really relying on triangles, or using the unit circle. And Brissaud in 2010 has suggested that the unit circle provides a much deeper level of understanding for students as they're starting to get to using trigonometry and learning about it in the classroom. So rather than using a traditional chalk and talk approach, having students play with the PhET application will lead to a much deeper level of understanding. In terms of using this in your classrooms as the teacher, I would typically suggest you maybe take 5 or 10 minutes up front to do a demo for the students, show them how it works, explain what the options are, then turn it over to the students and give them the chance to play around with it. Maybe set some questions asking them, what's this angle, what happens to the graph, etc. And then keep reusing the trig tour at multiple stages as you're teaching the whole trigonometry unit. So I would suggest when you're introducing sine and cosine, when you're starting to introduce the special angles that exist, and of course when you're starting to look at some of these graphs, because it gives students a really hands-on ability to play with and absorb the content. So let's quickly discuss some of the benefits and constraints of the PhET model. PhET has a number of benefits. I think it provides teachers with many resources, and you can use these for free to model and explain a range of different science or mathematics examples and concepts. There's also a number of resources that have been posted, so lesson plans, labs or experiments, step-by-step ways of interacting with these models. There's also, an ability for students to have multiple entry points into a topic. So the two examples that we looked at today, for students that are very visual in their learning, or students that need some hands-on interactions, should be able to play with the PhET content. If we look at the SAMA model, which was developed by Dr. Ruben P., this is really a model where we can look at how ICT can be introduced into the classroom. And we believe that PhET really takes things beyond just enhancing what you'd be doing in the classroom at this level, and really starting to transform and allow you to redesign how you'd be teaching that content. And the key thing is that students can play with it, they can interact with it. They obviously need a device, like a computer or a tablet, to be able to do that, but that would really increase student engagement with the topic that you're teaching.
Now, in addition to all the wonderful things PhET can provide students, there are a few potential pitfalls or constraints to be aware of, namely that some of the PhET simulations rely on using Java. So for students which are iPad schools or Macintosh schools, that's going to present a problem for staff. And research does suggest that the most effective way to make use of these applications and these interactive methodologies is for students to individually work on a simulation. So you want to make sure that it's one laptop per student. So in conclusion, PhET's a highly interactive tool accessible across a number of topics in science and mathematics education. There's over 100 simulations in various fields to try out, so we highly recommend it, and it's very helpful for both teachers and students because they can use it not only in the classroom but at home. If you'd like to, there's also the option to donate to the PhET simulation to help move some of those Java applets to HTML5, which will make them more accessible.
So here's a list of references. Thanks for listening, and we hope you enjoy PhET.